Welcome to today's presentation highlighting Amazon Web Services, Microsoft Azure, and other mission-critical features. Starting off, we walk through the steps for launching an Infoblox EC2 instance using the Amazon Marketplace. On the EC2 page, click on the Launch Instance button and switch to the AWS Marketplace. Searching for Infoblox will bring up a list of Infoblox AMIs. In the Marketplace, this includes the Trinsic 1420 and the CP800 series appliances, while additional model appliances are available through the Community AMIs page. Click on the Select button for the appliance image that you want to launch. This window provides product information, including pricing. On to the next screen. We see that the correct instance type is already chosen for you. For the instance details, we must assign it to the correct network and subnet and set any other details that are required. Most importantly, a second network interface must be added, and automatic assignment of a public IP address is disabled when this is done. Your selection for the storage type is important, as this can have a direct impact on server performance. SSD has much better performance and is recommended for production use. When assigning a name to the VM, generally a short name is used. Any VMs with dots in their names, such as the FQDN, may trigger a warning for vDiscovery tasks, but will not prevent them from being able to run successfully. On the Security Group Configuration page, you can create a new security group or assign an existing one. A minimum listing of ports that must be open through the VPC for agreed communications, DNS queries, SSH access, and API proxy is provided for you here and can be used or modified as required. Here, you have the opportunity to review the settings for this instance. Be sure to verify that your security group, instance details, and storage are all set correctly before clicking on the Launch button. Lastly, we see a pop-up to assign a key pair. This is not used for Infoblox servers and can be set to proceed without a key pair. Click on a Launch Instances button and a launch will begin. This may take about 10 minutes to complete. Infoblox appliances are also available within the Microsoft Azure Cloud Platform and are easily deployable through the Azure Marketplace or as a solution template. Navigating to the Azure Marketplace, search for Infoblox or NIOS, and you should see the Infoblox solution template return in results. Clicking on the search result, a new panel appears which displays product information and useful links such as a deployment guide. After clicking on the Create button, we will be able to select the model appliance we want to deploy. Next, we set the name that will be used for the VM instance and the password that will be set for the admin account, as the default password is not used for the Azure vNIOS appliance. If you have multiple subscriptions associated with your Azure account, you will need to make sure that you select the one that the instance will be deployed under. You also have the option to set the location where the instance should be served from. In step 2, set the NIOS version to be used and confirm the machine size for the instance. If the preset machine size is available for your location, it will be listed here and show pricing and other information. Next, we set the storage account that will be used for the NIOS disk. This must be a premium type storage account, and you can select an existing one or create a new account here. The storage account must also be applied for the boot diagnostics using a standard type account. For the virtual network, you can create a new one here or select an existing one. After setting the virtual network, create or assign the appropriate subnets, which will be used for both the LAN 1 and management interfaces. A public IP address is optional and can be assigned here if desired. Select None to proceed without assigning a public IP address. Otherwise, assign an existing IP or create a new one. When assigning a public IP address, you must also specify a DNS name which will be served through Azure DNS. Simplifying your setup, common temporary license keys are installed by default. Remote console access is also enabled for you. In step 3, you are provided a summary outlining your system configuration. Lastly, the Infoblox terms of use, policy information, and other helpful details are provided in step 4 of this wizard. Click on the Purchase button to proceed with deploying your new Infoblox vNIOS appliance in the Azure cloud. The status for the deployment can be monitored on the dashboard and in the notifications area. If the deployment fails for any reason, any errors that were encountered will be displayed there as well. After the instance finishes deploying, it should be listed in the Virtual Machines blade. Clicking on it will bring you to the overview screen, and navigating to the Network Interfaces panel will allow you to view the IP addresses that have been assigned to it. This is one way where you can view the public IP addresses for the instance, if one was applied. Assuming that your network security groups are set to allow HTTPS access to the instance and you have network connectivity to the appliance, You should now be able to connect directly to it if temporary license keys were installed. In one example showing how Infoblox servers can be deployed, we demonstrate a hybrid cloud grid where servers are operating in the VMware, Amazon AWS, and Microsoft Azure cloud platforms. Infoblox installations are extremely flexible, allowing you to deploy them in any combination of environments, including with physical Infoblox servers or within a single platform in order to meet your requirements. These requirements may include for performance, local serviceability, or redundancy and fault tolerance, key components in many disaster recovery plans. Along with managing your grid, Infoblox also extends IPAM visibility to the cloud. With more and more networks moving to the cloud, keeping track of everything can quickly become a daunting task. To help with this, the Cloud Network Automation feature gives you the ability to easily view detailed information learned from multiple cloud platforms, all on a single pane of glass. Now, let's take a look at the metadata collected for an Amazon AWS EC2 instance, which includes all the IP addresses that would have discovered for it and when it was last discovered. Next up, we look at the properties for a VMware instance showing the metadata collected for it, including its IP address details. Lastly, this example shows the metadata collected for an Infoblox NIOS appliance running in Microsoft's Azure platform. As networks become more and more virtualized, keeping track of everything quickly becomes a daunting task. With Infoblox's vDiscovery feature, this becomes a simple task with just a few clicks of your mouse. Here, we walk through the configuration of one vDiscovery task. The first screen allows you to set a name and assign a grid member to run the discovery. vDiscoveries for AWS and Azure do not have to be run from appliances running within those cloud platforms. Next, we select the cloud platform type for the vDiscovery. The service endpoint tells the server where the discovery connection should be established to and is a publicly accessible address for both AWS and Azure. Jumping ahead to the Data Consolidation tab, we get a good overview for the level of control you have over how discovery data is handled, including when there is pre-existing discovery data or managed objects that overlap with anything learned through subsequent discoveries. And what many administrators find most helpful, you also have the ability to create DNS records for any discovered VMs and their IP addresses. Several macros are available to choose from which control how the names for these records are generated, with one commonly used example provided for you on the screen here, and others provided in the help panel. This is great for getting records in DNS that may have been missed when VMs were provisioned, and even more importantly, these are all cleaned up automatically when subsequent vDiscovery jobs find instances that have been terminated. No more worries about records going stale. To demonstrate vDiscovery, we begin by launching a new VM using AWS in this example. Back on the Instances panel, we can do a quick review of all the details for the instance that we just spun up, seeing its name, ID, and IP address information. Reviewing DNS, we can also see that the DNS records for this instance have not yet been created. Bringing up the vDiscovery Job Manager, we can manually start the task to have it run immediately. This process is generally fairly quick, taking less than a minute to complete. After clicking on the refresh button here a few times, we can see the job has completed. Upon closing the Job Manager window, the screen that we're on automatically refreshes, and we can see that the Test Linux demo instance is now showing up in the VMs list. We can also see the numerous metadata that has been collected from AWS for this instance, including its instance ID, availability zone, IP addresses, and other useful information. Jumping back to the DNS zone, we can also see that there is now a DNS record for the Test Linux demo instance. Editing the properties for this record, we can see both its private and public IP addresses, that it was created as part of a vDiscovery task, and the numerous metadata that was pulled in from AWS for the instance and stored as extensible attributes. Bringing up a command prompt, we query the Infoblox DNS server for the Test Linux demo DNS record and can see that both the public and private IP addresses are returned as expected. Amazon's Route 53 service allows you to create public hosted zones and private hosted zones for your VPCs. Here we look at an example showing both types. Next, we look at a record that has been added to one of these zones. Jumping over to the Infoblox server, we can see that none of these zones have been synchronized yet. Using a Route 53 synchronization task, we can synchronize the zone data from Amazon as shown here. Once the sync task completes, we can see all of the zones have been synchronized over into NIOS, seamlessly integrating a Route 53 and Infoblox DNS services. Here's an example showing the record which was synchronized from Amazon Route 53. Opening the properties for the zone, we can also view the zone's metadata that was pulled in from Amazon as well. After zones are synchronized from Route 53 for the first time, they can be assigned to a grid member so that they can be served by an Infoblox server, and can be done by using a name server group which has been set as default. Once services are restarted, the zones will be served. Opening a command prompt, we query the Infoblox server for a record from one of the synchronized zones and see that we get the expected response. Infoblox's API proxy feature allows you to seamlessly integrate automation of your AWS cloud environment with NIOS. Opening the properties for API proxy, we can see examples of API endpoint mappings that have been configured here. These are used by NIOS for its connection to the appropriate Amazon endpoints based on the region specified in a script being executed. Alias records are also used so that these endpoint mappings will be resolvable. To demonstrate API proxy, we bring up the syntax for a script which will launch a new Linux instance in AWS. Using extensions that have been added to Amazon's API, it shows how we can use Infoblox IPAM and assign the next available IP address from a network based on an EA search. Additional parameters can also be passed within a single request, such as host and alias records, showing you how easy and effective integration is with Infoblox and AWS. Upon running this script, we see the instance ID and IP address that were assigned. Refreshing the EC2 Instances panel, we can see the newly launched instance initializing, and jumping over to the Infoblox GUI, we can see the instance listed here as well, completely seamless. Helpful metadata is collected for all objects created through API proxy. Viewing the IPAM details for this instance, API proxy is represented by the Cloud from Adapter status. We can also see the fixed address and host object that were created for this instance when it was launched. Opening the properties for the fixed address, we can see its IP and MAC address along with the Cloud Adapter usage flag. In the Extensible Attributes panel, we also see an example of detailed metadata that was collected for this instance. In the Host Objects properties, we can also see the name, IP address, and Cloud Adapter usage saved for this instance. Here, we can also see the alias record that was created when the instance was spun up. Bringing up a command prompt, we query the Infoblox server for this instance's name and see the expected answer with the IP address that was assigned to it. Querying the server for the alias record, we see the CNAME record with the corresponding A record returned as expected. That shows how easy it is to add VMs into IPAM, but what about cleaning things up after the fact? With Infoblox's API proxy feature, you can rest assured that everything will be taken care of for you. Here, we run an API call to terminate the instance that was previously launched, and then in the AWS Management Console, verify that the termination has started. After refreshing the IPAM display in Infoblox, we can see the DNS records are no longer present, and then back under the Cloud tab, the VM instance has been cleaned up here as well. With Infoblox's DNS Firewall feature, also referred to as RPZ, you can provide protection to your clients against malicious activity or restrict against other unwanted actions. On this screen here, we can see both a local policy and a subscription-based feed that have been configured. Local policies allow you to add rules manually, while a feed is updated automatically by a provider, such as Infoblox's Active Trust feed. Examining a local policy, we see the different actions that can be set to take precedence over any rules that may be set up within the policy. Here, we see the examples for a substitute rule, which has been set up to redirect clients for a domain typically associated with adult content. This is a common use case where you may want to direct affected clients to some sort of tracking or mitigation server. Next, we connect to a client computer that is using this Infoblox server for DNS resolution. Using a command prompt, we demonstrate that there is nothing in the DNS cache that could affect DNS resolution and switch to a web browser. There, we attempt to browse to the address that is being blocked with the substitution rule and see that we are redirected to the internal web server as expected. Now going back to the command prompt, we query for the blocked address to see how the response looks in a little more detail. Infoblox's reporting solution is also another great value add which simplifies the tracking of DNS Firewall and other activity. There's no more struggling to find your affected clients, As you can see here, you can easily identify these affected clients and what traffic they are generating with just a few clicks of your mouse. Information for DNS Firewall activity can also be set up to be recorded in your server system logs.